Good morning all. Let's we study about the software testing principles. There are two general approaches of software testing. One is the black box testing and another one is the white box testing. So we'll study. Generally, you have seen the black box. Imagine the black box and imagine a white box. So in a black box testing, we can't able to see if any object is there. In a white box, we can able to. So imagine white box and black box. So here we will first see on related to that concepts in a black box testing. A tester doesn't have any information about the internal working of the software. And black box testing is a high level of testing that focuses on behavior of the software. So it involves the testing from external or end users perspective. So it doesn't contain the details. So black box testing can be applied to virtually every level of software testing. So black box testing is used at every level of testing: unit testing, integration testing, system testing, and acceptance testing. So here you can see the black box testing as the proper functioning of the software is tested, whether the software accepts the input properly and generates the proper output. Internal interfaces, external data, information is going to be tested. So it is tested against the acceptance test. Next is the white box testing. So white box testing is testing technique which checks the internal functioning of the system. In this method, the testing is based on a coverage of the code statements, branches, paths, or conditions. So white box testing is considered as a low level test. So it is called as a glass box, transparent box, or clear box, or code based test. So the white box testing method that assumes that path of a logic in a unit or a program is known. Here the programmer should know about the tester should know about the program. So white box testing is the here you can see procedural details are closely examined. Procedural details are closely examined. Internals of a software are tested. That is internal structures, logical paths, control flows, data flows, internal data structures, and conditional loops, etc. So white box testing. Now we'll see about the white box testing first. So it is the basic paths, basic path testing and control structures testing. We have seen here the black box testing is proper checking against input, output, and what the output software that generates. And in a white box testing, here you can see the logical paths, control flows we can check. So here basic path testing is there, control structure testing is there in a white box testing. So here you can see the tester he can able to see white box testing. The main goal is to ensure that all statements and conditions have been executed at once. So all conditions whatever given here and statements that should be executed at once. So that is our goal. Basic path testing, every execution path will be tested at least once. So steps, design flow graph for the program or component. Calculate cyclomatic complexity. We'll see how to calculate cyclomatic complexity. Select a basic set of paths and generate the test cases for this. So now by considering this diagram, we'll go forward. Design flow graph for the program or component. So graphical representation of a control flow of the program. What does it contain? Nodes, edges, and regions. So represents one or more procedural statements. That means nodes. Edges that represents control flow and region that represents the boundary means bounded by nodes and edges areas. So calculate cyclomatic complexity. There are three ways to calculate cyclomatic complexity. First one is the total number of regions in a flow graph. So number of regions we have to calculate in a flow graphs. Second is the way of calculating complexity as a number of edges minus number of nodes plus 2. That will give you cyclomatic complexity. And third way is the number of predicate nodes plus 1. So these are the formulas given for calculating a cyclomatic complexity. So the basic part, what is mean by basic part testing as we have seen in a white box testing. So compute the cyclomatic complexity. So that is mean a compute cyclomatic complexity. How to calculate the number of simple decisions here? The number of simple decisions plus 1. Okay. Or number of enclosed areas plus 1. In this cyclomatic complexity, the edges are Vg is equal to 4. So number of paths is equal to 4. That means here if you are starting from here, then this is one way like this. This in this way you can go. This is the first way. Second, from here again you start. From here, other condition. Second way. Okay. Then this will be the third way. And last one is fourth. That is this is the another way. So Vg of a 4. So that is given. So here the select basic set of a paths. So here it is clear that number of nodes we have given, that is 1, 2, 3, 4, the numbering for the nodes we have given. Edges that control flows. So we have generated here since Vg is equal to 4, there are 4 paths. Okay, Vg is equal to 4. So 4 paths. How? It should be in first path 1, 2, 3, 6, 7, 8. Okay. In a second 1, 2, 3, 5 and 7, 8. Third path 1, 2, 4, 7, 8. In a last path 1, 2, 4, 7, 2. Okay, 4, 7, again 2, 4 and again 7, 8. So in this way we can go. This is the condition. Again 2, 4 and 7. So finally we derive test cases to exercise these paths. Now we have to exercise these paths. So test cases we need to create. So now from these paths, from earlier paths here, by considering these paths, we can generate the test cases for this path. So test case, what is the template, what is the table, how to write table for the test cases. So there are different types of parameters. Test case ID, test case name, whatever name you can give. If we are checking the login, that time you can say login module. The test case descriptions, what does it take as input and what will be the output, that is the test description. That's what steps are to be carried out here. We have to write login is equal to something applied, whatever input is there, login ID and password. Expected result is it should be logged into the system, and actual result expected is same as the actual result. Whenever same as the actual result, then the test case is pass. When two are different at that time, it is to be failed. So test priority and defect severity. So this type of a table you can write as a test table. So this you can see in a next point. Right now you have to understand the you have to create test cases for the selected parts. So here we have cleared with the white box testing how white box testing is to be carried out and how these test cases are to be carried out and how these test cases are to be generated.